All right, so we're going to divide exponents here. We're looking for the scenario where they had the same base. And if you notice, these two exponents have the same base. Let's put it in expanded form, and then I'll show you the shortcut right after that. U to the fourth basically is the same as 4 u's multiplying each other. And u to the second power is the same as having 2 u's multiplying each other. Now, u divided by u would be 1, or basically it would kind of cancel out there for lack of a better description. And the same thing's happening with the next set of u's there. And now we've got 2 u's left on top, and there's nothing on the bottom. And what we can do is literally rewrite those 2 u's on the top as an exponent, which would be u to the second, because there are 2 u's here multiplying each other. Now, that is the long way of figuring out how to divide with exponents. However, we can look at this again and see that really we can just subtract the exponents if they have the same base. So u to the fourth is being divided by u to the second. Take the top exponent and subtract the bottom exponent. So 4 minus 2 is 2. Just make sure that you always do the top exponent minus the bottom exponent. Now, use that for your new exponent. The answer of that subtraction problem is 2, so it's u to the second power. Let's take a look at this one. N to the fifth divided by n. Just like we've learned in previous lessons, if you don't see an exponent, put a 1 right beside it. Top exponent minus the bottom exponent, so 5 minus 1 is 4. Our answer would be n to the fourth. That's how we can divide exponents that have the same base. W to the 100th power divided by W to the 25th power. Do the subtraction. W to the 75th power. How do we handle the coefficients? Like in this example, we've got the 20 and the 5. Well, you need to handle it just like you would a fraction. If it can be reduced, we reduce it. If it can be made into an integer, we make it into an integer. If we can't do anything, we just keep it. So these coefficients are going to be different from problem to problem. Now this one is 20 over 5, and that is 4. And so we're going to put that 4 up on the top part of our fraction. And now we're just going to go ahead and subtract the exponents off of the m's because they have the same base and they're dividing each other. So 5 minus 2 is 3. And that'd be our final answer. There's nothing on the bottom, so we don't worry about that. In this scenario, the coefficients are 12 and 8, and so we would think of 12, the coefficients as a fraction 12 over 8. It does not become a nice, easy integer. In fact, all we can do is simplify it down to 3/2 or 3 over 2. So we go ahead and rewrite out the fraction 3 over 2. And then we worry about the exponents there that have the same base of h. So 5 minus 2, top exponent, minus the bottom exponent would be 3. And if you notice, I'm putting that up on the top part of this fraction. We always put it up on the top part of the fraction there. One other example I wanted to show you too. 20/3 is the coefficient. You can't do anything with 20/3. You definitely don't want to make it into a mixed number. We can't simplify it. It doesn't become an integer, so just leave it as 20/3. So that's the beginning of your fraction. Then you look back over and you see if there's anything that we can do. And you notice that the exponents both have the same base of r, so we can subtract 15 minus 3. And that gives us 12, so r to the 12th. And that's the final answer.